Nice having you once again, my wonderful scholars. Jump past question 2001. Question number 36. A cell can supply current of 0.4 ampere and 0.2 ampere through a 4 ohm and 10 ohms resistors, respectively. The internal resistance of the cell X. Our question today is centered on electric circuits. Here we have first experiment and second experiment. With time, you understand what I mean by that. Let's get the parameters out. Okay, in the first experiment, we have, okay, let me explain. Here, we have a circuit diagram that contains a cell or a battery, an ammeter, which measures current. It takes the reading of the current, and a resistor. In the first experiment, we had a resistor of, we initially had a resistor of 4.0 ohms, 4.0 ohms or 4 ohms, and the ammeter had current reading of 0.4 amps. Respectively simply means the first resistance will go with the first current. The last resistance will also go with the last current reading. Observe. The first current reading there is 0.4 amps, and the first resistor is 4 ohms. Then in the second experiment, we had 10 ohms, 10.0, 10 ohms resistance, and it will go with 0.2 amp. First to first, last to last, that's respectively. Then observe something. Observe. The experiments, first and second, obey what we call Ohm's law. And what did Ohm's law imply? It simply implies that the higher the resistance, the lower the current. If there is much flow, there will be less resistance. If there is less flow, that means more resistance. Okay, observe. Initially, you had 4 ohms versus 0.4 ampere. Then we'll now increase the resistance to 10 ohms. Therefore, since the resistance has increased, the current will do what? Reduce. That's why I have 0.2 amps and no more 0.4. So there are two experiments here. So the question is saying, find the internal resistance. R, small r, question mark. This capital R, we have 2. This current, we have 2. Okay. Then observe. For us to find the internal resistance, we have to go back to that circuit diagram. We observe what and what there is variable, and which other thing is a constant. This is what I mean. The current is a variable, the reading was changing. The resistance is a variable, the reading was also changing. But something never changed in the experiments. Something never changed, and that works. The cell itself was never replaced. The experimenter was replacing the resistor, which brought about change in current. But the cell was maintained. Therefore, the internal resistance inside that cell will also be the same. When you want to solve two experiments, you look for something that is constant and stand on it. Something they have in common. And that is the internal resistance of that cell was never changed. The cell was maintained all through. Then we'll go back to the formula for finding EMF of a cell, which says E is equal to capital I, which is current, external resistance, which is capital R, internal resistance, small letter what? R. Recall, in both experiments, the cell is the same. The cell never changed. Then see what I will do. Observe, currents, big R and small r are all there. So they have small r in common because the cell was never changed. See what I will do. I can now state it clear that the EMF in the first experiment is equal to EMF in the second experiment. Both experiments have the same cell. That's what I mean by this. E1 is equal to E2. Then E1 would be I1, open bracket, big R1 plus small R1 equal to E2, big I2, R2, small R2. Both cells, both experiments have the same cell. Forgive me. Okay. Then the current in the first experiment is 0.4. The resistance then was 4 ohms. The internal resistance R1, we don't know yet. In the second experiment, I becomes 0.2. The resistance will now increase to become 10 plus R2. Recall, R1 is equal to R2. the cell is the same, the resistance of the cell is the same, in both experiments. Therefore, I'll just be going with R. Then we'll continue. 0.4 times 4 will give me 1.6 plus times plus times it 0.4 R equals 0.2 times 10 is 2 plus times plus 0.2 times R will give me 0.2 R. Then collection of like terms. Numbers back down one side. 2 is bigger, so 2 remains. 1.6 comes over there. Minus. Plus changes to minus. 1.6. 0.4 R is bigger. The other one comes this way. Plus changes to minus. 0.2 R. 0.2 R. Then we minus. So 0.4 R minus 0.2 R will be giving me 0.2 R equal to 2 minus 1.6 will give me 0.4. Then we'll make R the subject of the formula. Then divide both sides by the coefficients. R becomes equal to 0.4 divided by 0.2. R is equal to 2 ohms. Okay, we can see from our solving the internal resistance of the cell is 2 ohms. Going back to our option, the best option there is option A. I want to remind you the logic behind this solution. Recall, when you have variables, target the constants. If you have two experiments, target the variables and the constants. Stand on the constant to equate all variables. Then you get done with your solving. Thank you so much. Stay tuned as we push ahead. Please do subscribe.